In this lesson, you can see that I'm going to look at volumes of pyramids. So first we have to look at how are we actually going to compute the volume of a pyramid. And if you think about, or if you do a little demonstration on this, you'll see where the formula actually comes from. What I want to look at is how many, if I were to take a pyramid that had a base congruent to the base of a prism, and the pyramid and the prism had the congruent height, how many of these pyramids could I fit into one of these prisms? Well, if I used rice or I used water, filled the pyramid and then dumped that into the prism, how many pyramids would fit inside of there? Well, if you do that, you'll find out that there are 3 pyramids that fit inside of a prism. Well, if you think back, the volume of a prism was volume equaled the area of the base times the height. Well, if I can get 3 pyramids inside of here, or inside of here, then to calculate the volume of the pyramid, I just need to take 1/3 of it or divide it by 3. So then I have that formula right here for the volume of a pyramid. 1/3 area, remember big B stands for area of the base, might want to write that down next to the big B, and the height would be the height of the pyramid. So in my picture here, big B would be the area of this base. Now it could be it looks like a square there or a rectangle, but it doesn't have to be. It could be a triangle, it could be a pentagon, it could be anything. And then H, remember, is the height of the pyramid, which will be there. It's going to be that segment that goes from the apex of the pyramid down to the base, and it has to be perpendicular to it. So remember this formula for the volume of a pyramid. Now let's use that volume formula to help us find the volume of this square pyramid. So I look at this, and 1, it tells me that it's a square pyramid, which means the base is a square, so it's going to be real easy for me to calculate the area of the base. Well, 8 times 8 because it's a square, and I know the area of my square base is 64. But now it's to figure out the height. So what I need to do is, ultimately, I need to figure out how long is that piece there. And all I know right now is that one of those lateral edges is 12 inches. So what I'm going to do is I'm going to do a couple things. I'm going to take this over here, and I know that this edge right here is 12. And I also know that this whole side here is 8. Therefore, if I just go from that point there to the halfway point, that would be 4. And then I could draw in slant height, which remember is going to be perpendicular. I have a right triangle. This is going to allow me to figure out that slant height, the green part, which I'm going to put in here as well. I don't know it yet, but I'm going to figure it out here very shortly. So I'm going to use this picture to help me find the green slant height using my Pythagorean theorem. So I'm going to have a squared plus, well, my slant height, I'll use L, equal to the hypotenuse in this one, which would be 12. Now as I go through and I solve this, I'm going to find this out. We have 16 here plus L squared equal to 144. Get rid of the 16. I find out that L squared is going to be equal to 128. I take the square root of that. And then I'm going to figure out that L is, now remember, taking the square root, so it's going to be plus or minus, square root. And now I got to look for factors. So I'm going to factor this 128. I know it's even, so 2, well, that'd be 2 times 64. 64 is 2 times 32. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. There we go. There's everything. So now I go through and I look for those pairs. Pair of 2s, pair of 2s, pair of 2s. I can take 1, 2 out for each pair. That's going to leave me with plus or minus 8 root 2 for the length of that green segment. Now, being this is talking about a length, the negative one is not going to make sense for this problem. Now I'm going to come back up here. That piece is 8 root 2, which when I come over here, I know that this is now 8 root 2. And then I'm going to connect the height of my pyramid to the bottom of the slant height, and I know that's 4 because the height in this right square-based pyramid is going to land right in the middle of that square. And now I have another triangle with the red, the green, and the blue, and I should be able to calculate the length of the height, the red piece. So, go back to my Pythagorean theorem again. A is 4 squared plus my B is going to be the height of the pyramid. I'm going to call it H then, squared, and that's going to be equal to C, which is 8 root 2. And then remember, it's all of that squared. Now I have to solve this. So 4 squared is 16 plus H squared equal to, well, 8 root 2 squared is just going to come back to right here. I took the square root of 128 to get 8 root 2, so if I square it, I'm going to end up back at 128. So probably would have been to my advantage not even to worry about simplifying it, but that's okay. A little extra practice on that, it's not going to hurt us. Now as I continue, get rid of the 16. Find out that H squared is going to be equal to 112. Take the square to both sides. Find out that H equals, and again, it's going to be plus or minus. And I'm going to look for factors. It's even, so 2 times, that would put me at 56. Oops. I'm not going to write down the 56 though. Factors of 56 would be 2 and 28. Factors of 28 would be 2 and 14, and factors of 14 would be 2 and 7. So I have it all factored. Look for those pairs again. Pair of 2s, pair of 2s. So now I'm at plus or minus 4 root 7. And again, being we're looking for the length of something in our pyramid, the negative's not going to make sense. So I just figured out that the height of my pyramid is 4 root 7. It'd be inches. Now I am able to figure out, I just wrote a 2 there, didn't I, instead of a, let me try writing this again. 4 root 7. There we go. Now I can find the volume of my pyramid by doing 1/3 area of the base times height. So I'll come down here. My volume is going to equal 1/3 area of the base. I knew that each side of my square is 8, so I'm going to do 8 times 8 for the area of the base. And then multiply it by the height, which I just found at 4 root 7. And I will have it. So I'm going to look at the exact answer first. What I'm going to do is I'm going to take 8 times 8, which is 64, and then I'm going to multiply it by the 4, and I'm going to end up with 264. And I have to multiply it by root 7, and I have to divide by 3 or multiply by 1/3. So right here would be the exact answer for the volume of that pyramid. Now if I wanted the oopsie, sorry, it's not 264. Let me try that again. It's 256. Slight difference there. So it's 8 times 8 times 4 is 256. Multiply by the root 7, divide by 3, and we will have our answer, our exact answer. Now if I want the approximate, I'm going to want to take that, multiply it by the square root of 7, and then divide by 3. So if I type all that in on my calculator, I'm going to come up with an approximate value, which is probably nicer in this situation, of 225.77 cubic inches. So yes, that problem's a little bit in depth, just because we had to use the Pythagorean theorem a couple times to actually calculate the length of the height. But once we had the length of that height, then it's just a matter of plugging it into the formula. 1/3 area of the base times height. And in my last one, now in this one, I kind of went overboard, I guess, with the square-based pyramids, because this one's also a square-based pyramid. But on this one, notice it gives us the volume of the pyramid, and it wants to know what's the surface area. Well, what we're going to have to do first is think about how to get surface area. So what I'm going to do is I'm going to draw the net. It's going to look something like this. And I think about what do I need to know to calculate the surface area, which would be the area of that net. Well, I know that each side of my square is 16 inches, so I know this is 16 inches, this is 16 inches. So calculating the area of the square, I have everything I need. But then if you go to your triangles, you need to be able to figure out the areas of those triangles. 1/2 base times height. I know the base of the triangle is 16, but the height, I don't know. Now that green piece that I just drew in there is also right here in the pyramid. So if I could find that, I'd be set. Now I look at this, and in my pyramid here, I know that this piece right here is 8. If I would know the height of the pyramid, I could use the Pythagorean theorem with the red, the blue, and the green, so I'd know how long that green one is. Well, I look back here now and it gave me the area, or excuse me, the volume of the pyramid. And I think back that volume is 1/3 area of the base times height. So if I do that, my volume, which I'm going to write this down, volume equals 1/3 area of the base times the height. And then I'm going to come back here and I'm plugging what I know. Well, the volume, it tells me, is 1,803.4. So that's going to be equal to 1/3 area of the base. Well, I know it's a square and it gives me each side length, so that's going to be 16 times 16, and then times h. So now it's a matter of solving an equation. This part, the 1/2 times 16 times 16, that's going to come out to equal 128. So I have 128, h equal to 1,803.4. And then if I divide both sides by 128, I end up with the height of this pyramid being approximately 14.09. Now I have the decimal on my calculator, 14.0890625 and so on. I'm going to keep that there and continue to use that. Did I say 08 or 09? 09, good. Alright, so now I know that. And now I can use this triangle, remember, in the Pythagorean theorem to find the length of the green, which is the slant height. So I'm going to do that. I'm going to have 8 squared plus my 14.09. But again, remember, that's still on my calculator, all the decimals, and that's going to be equal to then my slant height squared. Alright, so 8 squared, that's going to be 64. Now I'm squaring that number that's on my calculator, and I end up with 198.50. Just leave it there, equal to L squared. Add on the 64, and we figure out that L is going to equal plus or minus oh, excuse me, no, I'm not there yet. Step ahead of myself. So L squared is going to equal 262.5. Now when I take the square root, now I'll have L equal to plus or minus 16.20. And being again that this is looking at a length, I don't have to worry about the negative. Come back up here. Now I know that this piece right here is at 16.2. Now I have everything I need to know to find the surface area of my pyramid. So I'm going to go through, I'm going to do the square first. So look at this as the area of the square. Well, 16 times 16 equals 256. And then next I'm going to look at the area of the triangles. I'm going to do this 4, I'll say T, so 4 triangles, so I'm going to take 4 for the 4 triangles. Now 1/2, the base was 16. Guess I should have left that as blue, but I think you'll remember that. So I want to have base, and then multiply that by the height that we just calculated to be 16 point, oops, not 0, 16.2. And multiply this all together on my calculator. I end up with 518.46 for the area. Now remember, that's for all 4 triangles. So then to get the total surface area, I need to add these 2 numbers together. So add that, and I end up with a grand total of 774.46. And I don't remember what the label was, so I'm going to come back up here and look. Everything was in terms of inches, so this would be, now remember, inches squared. So I used a little bit on what I knew about the volume to help me find the height of my pyramid, which then allowed me to find the slant height, and then that slant height came over here, which was a part of my net, which allowed me to find the area of all the pieces. So, yep, a little bit in depth, but all a bunch of little pieces that when you break them apart, you're going to be able to do, and then just put them all back together to answer the final question. And that's going to conclude my lesson on volumes of pyramids.